So this video is a little add-on that you can link into, which shows excerpts from the discussions that took place at the Electric and Hybrid Convention in Amsterdam that I attended. And it's quite interesting for people who have a particular interest in this kind of information. I found it useful.
On the other hand, there is not a massive amount of options for every ship. So for example, a big container vessel or bulker, that's methane, methanol or ammonia. Whereas then for a tug, it's a battery or a methanol or HVO installation, most likely. Passenger vessels, I would avoid ammonia because of the safety aspect and go with methane or methanol instead. So, again, the right fuel depends on ship type, on operation and so on. So, summing it up, where I see the potential, we have the three big ones. We have methane, methanol, ammonia, all playing a part in the future. HVO, yes, could be something there. Is there enough of that? Wind, battery, yes. But then there are question marks. I'm not so optimistic about hydrogen as the energy carrier on board an ocean-going vessel. Even though it will play an important part in the production, I'm not seeing that. I think some of the members in the panel will disagree with that. Nuclear, it's something coming. I didn't go into that, but there is something, but it will take a long time if it's coming. Wind, good. Biodiesel and non-standard, difficult to do. So we have options, but we also know things that are not maybe so good. So with that, I try to set the scene. Now we're going to start discussing.
And the first thing I want to say is the cleanest energy, using the term energy as opposed to fuel, because we need to shift the way that we're thinking. The cleanest energy is the energy that we don't use. And so, the first go-to is obviously efficiency measures, of which I won't go into it now because there's so many different ways that we can reduce our energy requirements. And as Elias pointed out, the biggest of these is wind propulsion. And at the moment, we're looking at wind propulsion as something something we're retrofitting on vessels that are designed like boxes virtually. They're not really designed they're not designed to sailing ships. Now, what does this have to do with hydrogen? The biggest issues with hydrogen is the volume. The volume per energy. When we're transferring, we're not going to get across the seas with batteries. We know that they're too heavy, they take up too much space. The next go-to in the use of renewable energy, the next transformation process is to hydrogen. So go on from that point, and you will lose more energy. So the first go-to is reduce the amount of onboard energy. Design your vessel so it actually is aquadynamic.
Into this, because as we have seen yesterday, the carbon dioxide emissions are increasing year by year. So if we see the real data of the maritime sector, there is an increase every single year. So we need to do something, and we need to do something drastic. And the two fuels that we have mentioned, hydrogen and ammonia, are the only fuels which do not have a carbon molecule into it. From that point of view, I am advocating indeed to find a solution which will help reaching the zero target. And I don't see really how this will happen with methanol and the conventional fuels.
I think ammonia and hydrogen are more or less the end game. How do we get there? I still think it's very difficult. As I see it, carbon is not the problem itself, as long as it's circular. So I don't see why we cannot have carbon in the fuel, as long as we recycle it, take it out of the air, take it out of biosources. Each time you discuss fuels, it's all about feedstock. Making hydrogen requires a lot of renewable energy. I still think it's quite a long way to go in order to go for electrolysis. To have a gradual, let's say, transformation, I think these are the first sources we will go to. So I think that carbon will be part of it, and I also might not be surprised if it will be always there.
Do you think, methanol and methane you get as bio versions? Do you think those will be cheaper or more expensive in the long run than the power to X fuels?
That's the million-dollar question, I think. But from the studies I've seen, then typically bio-source feedstock seems to be more affordable than synthetic fuels.
Yeah, certainly today, yeah.
We play to the end game, which is why we're absolute zero. Eventually, we need to all get to absolute zero. All industry needs to get to absolute zero emissions, and we need to get to absolute zero pollution, because pollution is having a huge impact on our climate. So we're playing to the end game. The end game is hydrogen. At the moment, appears to be the only fuel that doesn't have greenhouse gas emissions. And so for us, that's our point: is green electricity and green hydrogen. And when I say we're playing to the end game, is I believe that there are other ways of producing energy that haven't come online yet. And that, yes, we're talking about to replace all of our energy needs with renewable energy.
I have a point exactly on the question of Oscar, that this variability that we see with all these fuels is on the long term not sustainable. It's not possible. If we compare our sector with aviation, on the aviation the managed to standardize through the years. In our case, we see a tremendous variability of concepts and variability of fuels, which on the long term is not sustainable. So we need to do something, but unfortunately for us here in this podium, I don't believe that we have the magic answer. I would still, if you allow me, to advocate that it's very nice talking about fuels, especially the synthetic fuels. But I'm intrigued by creating big installations of wind energy. What to do to produce electricity with high losses, to produce synthetic fuels with high losses, to transport them with high losses, to run into combustion engines or fuel cells with high losses in order to produce a propulsion thrust. And I'm advocating that at least if we put a similar effort on using the wind energy directly, you would have one solution. It will not be the end of the problems, but it would contribute significantly in reaching the low emission levels that we have in mind.
Okay.
Can I come in on that?
Yes.
I would love to, because I think this supports my point that the cleanest energy is the energy not burned. And what this allows us to do by focusing on wind propulsion and efficiency measures at this point in time is to buy us time. So yes, there's governments pushing for this. We know in Singapore they're doing they're looking at having a smorgasbord. They are bringing in bunkering systems for all the different fuels in Singapore. We have hydrogen bunkering in Norway. It's happening. It's moving forward. We seem to be, and as was stated, shipping's a derivative market. The market ultimately will decide, but the market will only decide after we have some solid regulations in place that show how all of this is going to play out. Until the market will decide after we've analyzed the true LCA impacts of these different fuels and have put different numbers on them. At the moment, it's all chopping and changing, and it's all R&D. And I think that we're not going to have a clear picture of which fuel is going to be the ultimate winner until the end of the decade.
No, it might be. We do know, we have calculated quite a lot of options, and I think everyone here is calculating and comparing. And for different ships, different solutions do come out on top. And still offering zero emission or carbon neutral. But that's maybe a topic.
I just want to say, I think there's a lot of numbers missing in the calculations.
Yeah.
And I'll just stop at that.
Most likely, yes. I agree. It's not complete, and but we do have an indication. And certain things you can estimate technology improves. Certain other things you can kind of, we know where the physics are, and that will impact. I'm still coming back to this a little bit about the cost of installation. I mean, we saw in the chart that the methanol ships are being bought in a a lot of ship owners are buying methanol. My guess is because it's the cheapest. Where do you see, the cost of for the vessel if you compare methanol, ammonia, hydrogen? What's your take? Do you want to comment on that, anyone?
I think that's also an important factor of which fuel you choose. You can choose the cheapest fuel, but when we look to hydrogen, then you probably have the highest capex. So if you go for methanol instance, you can use steel tanks, which is way cheaper to store. So your capex is way lower. So yeah, if you have a vessel that doesn't have too many running hours or too much fuel consumption, then still a more expensive fuel can be overall be the cheapest. So, and I think that's how we also consider it. Overall, it's a kind of multi-criteria analysis. It's not only what's the most efficient.
Where do we see the cost of? We take the power to X fuels. They all start with the same hydrogen. Now, but then getting it to the ship, what will be the most affordable fuel at the ship side? Ammonia, hydrogen, methanol, or synthetic LNG?
I'm quite sure it will be ammonia.
Okay, ammonia, one vote. Elias, what do you say?
I'm advocating for wind today.
Okay, we come back to wind. Okay.
So I just have to say we can't possibly know, and one of the reasons we can't know is because, and it brings me back to the regulations. I mean, when you look at so they look at the EU tokens as an example. So you've got the cost of the ship, and then you've got this. I'll take it back to Elon Musk. Actually, do you guys know how Elon Musk got so wealthy? It wasn't on selling cars, it was on the carbon credits. It's how he used that. So if we look, so it depends upon the environmental impact that is then connected to that fuel. So at the moment at the IMO, we're beginning to we've looked at carbon emissions, and now we're looking at methane, and we're looking at N2O. So when we attribute those emissions back to the fuels, there will then be a cost associated with those emissions all along the whole chain.
But technically, if you're avoiding the question here,
No, I'm not avoiding the question. I'm sharpening the question.
Okay.
I'm sharpening the question, and that's what I'm saying is
But then it
at
becomes
this
a lot of
point,
speculation.
when it comes to your investment, you've got to look at where your income is going to be coming from, and if your income is going to be coming, you go back to hydrogen. If you've got green hydrogen that's been produced near where the vessel is, you will have zero emissions connected to that fuel all along the whole supply chain. Therefore, you will actually be in a credit that will cover the costs that you may have had to invest into the infrastructure that allows you to use that hydrogen.
Okay, go ahead.
If I can add something,
Nothing yet.
because you have together a lot of experience on the development of power supply technologies. In the reality, what we see, what is happening, a great majority of the vessels which are currently ordered, being thought to be methanol-based vessels or ammonia-based vessels, are actually designed ready for methanol or ready for ammonia. In reality, they would need a retrofit action at the time that the technology becomes available. So what I'm trying to say is that a technology to become mature for application, it would require some years. So it is very difficult from now to predict regarding the full impact of the fuel. Right now, we are running pilots. This is the reality. Pilots, prototyping of technologies which need to be matured with experience that we need to get from a field application.
Will there be cargo vessels without wind in the future? If we ask it this way. Wind propulsion, sails, rotors, suction wings, whatever you want to call it, out there. Is it a no-brainer for a merchant cargo owner?
For merchant vessels, especially for oceanic operations, I believe, or we hope at least, that there will not be vessels without wind solution. Again, the future will show, but I believe it is obvious that wind can provide low-cost, zero carbon, zero emission thrust for the vessel.
How big part do you think wind will contribute to normal vessels? I mean, are we talking 10% or 90% of the energy on board the vessel?
Well, I believe in this stage, because I don't know what will happen in 15 to 20 years from now, I believe that the percentages 10 to 30% are very are reachable. And if this becomes more in the future, it is another story. But the 10 to 30%, it is shown that it is possible. It needs still a very good integration at ship level. It is not to just add the solution on board of the vessel, it's to integrate properly the wind assist propulsion with the main propulsion.
You need to integrate it. I fully agree there, and it can contribute a lot more than 30%. But what we say is you need a CP propeller. Do you agree? If you have wind,
Yes.
it is a CP propeller.
Well, it would be really better to go with a controllable pitch propeller, because you need to have an additional degree of controllability. You need an additional mechanism, since the wind is of a variable intensity and variable direction. So the controllable pitch propeller would certainly help.
Anyone else want to touch wind? No? Chris?
Well, we looked into wind as well, and it's very interesting. And now you really see it booming. You see now more and more vessels being equipped with wind propulsion, assisted wind propulsion. But I'm questioning a bit for like container vessels. They don't have any deck area, and I think also for sailing speeds, you cannot go too high. I think so that in order to stay effective in wind propulsion. So in that terms, they might also be limited in capabilities. But I would say, yeah, if you can fit it, then add it. It's you install it and you have your benefits. I like the foils that you can fold in with the container, mount them on your decks. So yeah, I think it's a very good add-on.
I think wind and all other technical solutions you can use to reduce the fuel consumption is needed, because of course the cost for alternative fuels are much higher than marine gas oil or what you have. So it is important to lower the consumption of the alternative fuels to make it more on the same level, or towards the same level as the traditional fossil fuels. I was involved in the project when I was in Yara with Berge Bulk, with the sail on the bulk carrier, sailing for cargo, and the savings was really up to 30%. So on when you have the wind in the right direction, and it was really amazing to see how much fuel consumption you could.
I think one of the important things is, as Leo's pointed, you need to optimize the propulsion for it, but you also need to optimize the operation. We need to operate the vessels completely different when we talk wind. Have smart planning of the route and speed and all that, and really think about that.
Absolutely. If any of you are here as sailors, you'll know that you use not only the wind, but you also look at currents. This is something that we're not doing currently, is looking at currents. But I just wanted to comment on the when we're thinking about adding wind propulsion, we're really locked into a current vision of vessel design. One of our members has designed a container vessel that uses 90% wind and 10% hydrogen. So again, back to my point of wind allowing for hydrogen. It's changing the vessel design. At the moment, our container vessels are big boxes with a bunch of boxes stacked on them. Well, that worked for cheap fossil fuel. The times have changed. We need to completely rethink the way we design vessels to deal with the new energy sources that we're using.
Yeah, I fully agree there. I mean, we need to think, when we apply these technologies, what is the optimum of using that? That's not the same vessel where you just add on something.
on the propulsion, there is the possibility to go to completely new concepts beyond the propeller.
Yeah, that's
And
what
this
talking.
is something that we need to review quite carefully, and the information is not spread around in the industry, but there are possibilities of getting higher propulsive efficiency, but you need to change drastically the concept.
So we need to think outside the box.
Yes.
Dare to go away from the convention, yeah, and so on. It's always, you hear from many ship owners, yeah, I don't want to be the first one to test it, but it's more importantly, you definitely don't want to be the last one with the technology.
I need to add the two aspects into this. Firstly, let us not forget that for carbon capture, you need also energy. It costs energy
Yeah.
to do it. This is the first point, which is the negative one. The positive issue is that the carbon capture allows you, when you get the carbon, to create a kind of circular economy, that you can bring back the carbon dioxide into the circle. You can produce fuels if you use it carefully. And again, I follow also the statement of Madden that says, let us be careful that the carbon capture is really used on the proper way. But a lot of people right now, they see the possibility of the circularity for the carbon.